We are talking about PyReverse, that is reverse engineering or Python code. It draws UML diagram from the Python code. So PyReverse on any Python code. So now we'll see PyReverse on a package called Kivy. So Kivy is a graphical package and it is used to draw 2D and 3D, including shaders language. It supports shaders language, and it is supported on Mac OS, Windows, Linux, even on Android or iOS. So it's a simple, small Python package. Kivy package, the higher level, it is written in Python. So for that we will do reverse engineering and draw the class diagrams, and lower level code that touches the basic utility like graphics or window provider, graphics provider, or mouse inputs, keyboard inputs. So those codes are for speed issue, those codes are written in Python. So higher level in Python and lower level in Python. So we will do reverse engineering of the Python code, and we have utility which would convert the Python code to Python, and PyReverse would do the reverse engineering as a whole. So we'll see reverse engineering for Python, for Kivy using PyReverse is Python code and C Python code. Okay, so PyReverse internally it uses GraphViz to draw the class diagrams. So we have scripts also. So basic class diagram we'll see that how we can draw for the Kivy package, and then we'll see that how we can enhance the class packages, kind of advanced class diagrams, like which has in typical PyReverse, it draws the base classes, but it doesn't bother about its derived classes, so its children. So in enhanced PyReverse or enhanced utility, we'll draw base classes, we'll draw derived classes also, and for Kivy, we'll see how far we can turn the Python code to Python, and as a whole, we'll try to draw the UML diagram, reverse engineering through PyReverse for the Kivy. In continuation to the above discussion, PyReverse UML diagram generation through for Kivy packages. So PyReverse UML diagram generation through for Kivy packages. Okay, so this is Linux Mint. PyReverse on Kivy. We'll go point by point. So this is about running PyReverse reverse engineering tool on Kivy code base. PyReverse come in a package called pylint, and then GraphViz package also need to be installed for the actual GUI, the actual diagram. Kivy code base we can get from GIT Hub, and then we will see further modifications in the diagram generated. We have two written file called fix.py and modify.py that we'll see later. Primary aim is to install the PyReverse, get the Kivy code and run over it. We'll see Kivy architecture. So Kivy is mainly in 3 layers. So this is Kivy code primarily, top layer. This is middle layer where Python code come into the picture. These are providers, and these are third-party libraries which actually does the work. And these are in between which access this through C code and fill the Python data structure which is used by this module. So 3 layers. So this layer we would get the UML diagram immediately. Python PyReverse doesn't support Python, and so Python code we will convert to Python just syntactically so that class diagram and its properties can be drawn. So that is the idea for the Python code, and we won't touch this external library. We don't have code. These two, first this will draw, and then with the some script like we'll convert the pyx into py file, and then we'll run the PyReverse again. Okay, so what aim we have? We'll clone Kivy, install the PyReverse, set the variable, and 3 things we'll do. One is we'll run the PyReverse and generate the diagram, and then we'll change the Python code to Python and then run the PyReverse again, and then further beautification through modify.py. So 3 steps. One is PyReverse on the Kivy code. One is after modifying Python to Python, then running PyReverse, and then further modification, beautification of the PyReverse generated file. So that it would look better. So this is like after beautification, this would look like this. Like widget is a class which derived from these classes, and it has these many derived classes, our class and base classes, and these are its containment. So this is the final idea of the PyReverse tool. So we will proceed now. We'll create a directory. Okay, dir Kivy. Kivy 220. So it is empty directory now. We'll download the Kivy. So this is the Kivy GIT hub account, and this is the database Kivy again. GIT clone https github.com Kivy. So this would clone into Kivy directory. Okay. github.com. We'll try again. Okay, so it is now downloading. It will take time. So I'll copy the downloaded one already. Okay. Now we have Kivy. This is what we will get through GIT hub, and then we'll install pylint and graphviz. Sudo apt get install pylint. Okay, it is installed, and we'll install GraphViz. Okay, it is installed. Okay, now we have Kivy. So now we'll just browse through the Kivy. So this is the database called Kivy, and inside the Kivy we have the Kivy directory, Kivy in Kivy, and we have the source code. So like if I see the design, we have core provider, we have graphics, we have input. So core provider is inside. Core provider is inside core, and input provider is inside input. Graphics provider is inside graphics. Okay. This widget is inside UIX. All widget classes are here. Like this, Kivy language is inside language. So this way it is, this hierarchy is distributed. Okay, so widget internally use cache, clock, gesture, event loop property. Same thing is used by Kivy language also. Then these three are used. So this is the architecture. Now we'll do PyReverse. So we are in and the section number 1. This is 2 and this is 3. So primary, now we'll run PyReverse on the Kivy widget. We are here, but all the code is written from the package point of view. Here, so this is the Kivy package. Inside Kivy directory, we have the Kivy package. So this we need to put in the Python path if we are running from anywhere else. If I run from here, then everything looks fine. Okay, so I'll run from here, then it would be export Python path equal to okay, now we are Python path is set. Now we can execute PyReverse Kivy, and then UIX, then widget, then ASMY, and then class widget. Okay, it drew. Widget dot. So we can specify the output format PNG. Now we get PNG file. We can do man of PyReverse. PyReverse Python source extractor diagram. It draws UML diagram. Okay, so the main options are F if we don't want any filtering, and then if it is for a particular class C. If we want a number of ancestors, then -A, otherwise minus capital A for all ancestors. If we want number of associations, then -S, minus capital S for all ancestors, all associations, -B for built-in classes also, -M for module names, okay, -K for class name, only class name, no attribute, -O for format. So this is what we did. PyReverse, file name, output format, -A all ancestors, and then all associations, module yes, class, widget. We can go to the directory. We are in temp. Okay. Okay, so we would delete all this. We'll try again. So we have only Kivy. Now we'll PyReverse Kivy widget minus OPNG minus ASMY minus C widget minus K. Now only class diagram. Now we have widget.png. So this is Kivy. In Kivy UIX widget class derives from widget base and it contains context and meta class. So this is how we generate the Kivy UML code. If we want more, then we can remove the minus K. Same thing we are getting. Now attributes and definitions are also coming. Widget derived from widget base and these two they are contained through widget. So that is the idea. Okay, so we will do same thing for label, for button. There is no button file. Okay, similar way button came. And this is the diagram we are getting through PyReverse. Now we have so nice. Now we have button class derives from two classes. One is label and one is button behavior. And label finally derives from widget and this is widget base. So this is quite big diagram. We can do only for label. Now we have label in same fashion what we saw. Okay, so label derives from widget and then widget base. If we don't want these many information only class, then we can specify minus K. Now it would be short version. Label derives from widget and widget derives from widget base, and this is the idea. Okay, so this is what how we can get UML diagram in Kivy. We will move to Python code. So we'll rename these files. Okay, so we'll run for widget also, minus widget with minus k, and button also with minus k. So diagram would be smaller, button with minus k. So all these files are smaller now. Button derives from label button behavior widget, and this like this label. So we would rename these files. Okay. Okay, so now we'll move to point number 2, where Python code and we'll generate py code. So if we go to the Kivy here, we can see there are many pyx files. So these pyx files, these are Python code, and there are many classes that are in Python code. So we have written a fix Python code which would fix this and generate py file. So we'll copy it here. Now we have fix. So we'll execute the fix. Okay, so this is the uses. So we can say Kivy fix everything. Okay, so earlier we had, if we go to Kivy, we had event dot now earlier we had event pyx, now we have event dot py also. Like this, many pyx file got converted to py. So we can run the example again. So we'll go back and we'll run the PyReverse again. PyReverse for widget, if it really changes. Now we have two widget now. One is original, what we generated prior to running the fix, and we have widget derived from widget base. Now this is the new one. Okay, so difference is visible. Now we have widget derived from widget base, which derives from event dispatcher. So this is the complete picture. So in normal sense, we won't get through PyReverse, and if you see widget base, it contains canvas, canvas base, instruction group, and instruction. So this much information we are getting new, whereas these are not available here, and this is far better. So many things are available with fix. Okay, so this is the idea behind our scene. So now it is better we are getting. So this is the step number 2. Python code is coming into the picture now in the diagram. Same thing we can run for others also, like label. Okay, so this big is coming, and it has more information than what we had earlier. So this is the difference. Okay, so if we want to, we can draw module diagram also in the PyReverse, like PyReverse and then UIX minus ASMY. That's it. So module diagram is also possible. Okay, so whatsoever we got the module diagram is quite big. So if someone looking for the modules, how they interact with each other, so that you can see. Module diagram is module wise, like if we see Kivy, UIX, then these are the modules. So how they are interrelated, so that also can be drawn in the PyReverse. So this part is over. Now we'll move to third part where more beautification we can do. Now we had widget.orange earlier, and with changing the Python code, now we have this is better. Now we can do more beautification to this code. If we run widget minus, if we remove minus k, then we would get all the attributes. As per the, so we have all the attributes now. All classes attributes we are getting this way. Quite a big diagram. Now we'll go for, okay, so this is widget derived from base and then derived from event dispatcher and object UID. And widget base, it contains canvas and then canvas base and instruction group and instruction. Quite useful information. So we will move now to third one, how to get beautification. So there is another script called modify, which would beautify the UML diagram further. So it should look, so we'll modify, we'll just rename it now. Move, we'll generate again with minus k, and we'll move widget.png to widget fix.png, move label.png, label fix.png. Okay, we have not done for. So this is the idea now. So we'll copy, there is one called modify. So now we have fix.py, which fix the Python code. We have modify for the further beautification. Modify has to run at the package level, so we have to run modify at this level. Now we can say Python 3 modify, and then I can say Kivy UIX widget.py, Kivy UIX label.py, Kivy UIX button.py. So six classes it would do now. Okay. Now beautification is done here. Now we can see so many files here. So it draws the dot and then does some modification in another dot underscores and finally it generates the PDF file. So if we see widget PDF, this is beautification. Now it is we want red color signifies that what we want. So we want for widget derived from base dispatcher UID, and then widget contains canvas, base, instruction group, instructions. It also contains widget meta class, weak proxy, context, and it has derived class called label. From label, button comes into the picture. We can draw for the more if we want. So we have in Kivy UIX, if we do, we have many. Okay. There are many options in the modify. I can execute like this. Okay. Equal to means module name and class name should be same. So I can say Kivy UIX equal to. Okay, so 46 classes it has taken, and then it would execute and it would generate the PDF file. Is hierarchy and so many things. Probably it would take some time. Okay, so it is quite big. I believe it would take few more seconds. Okay, so looks like we are near the completion. Okay, so finally we are done. Now it is doing all the mathematics for the subclasses, and then it is generating the PDF file. Okay, so Same, we can bring it again, I believe. Now we'll look for the kiwi.ui.widget.pdf. Okay, so we'll bring it again, this PDF file. So this is kind of beautification. Now we have same thing, widget based dispatcher, but we can see that derived classes is more significant now. So these are the classes which are derived from widget, like accordion, checkbox, images, label, layout, and then their derived classes like this. So this is beautification. So this way we can get in the widget, these are the definitions and these are the variable attributes. So we can get complete architecture of the Kivy. Like we can search for the button. Okay, so we have another one for button. So if we see, button is derived from button behavior and label, and it has these many attributes. From button spinner and toggle button are derived. Then finally they are derived from widget dispatcher. So this is the beautification. If we run completely in the sense that if we run modify on Kivy itself, okay, it would take long time, and we can have complete database like this. Okay, here like I can search for event dispatcher. So this is our great event dispatcher. You can see. So event dispatcher class is object with UID and so many derivations. The most important one of is like Kivy app.app and then our widget, that is widget base, and then widget. So modify, beautification is through modification, and fix.we converted Python to Python, and these are the basics we executed. Here we can see widget. This is our widget. Widget derived from dispatcher, and it has so much the hierarchy for the derived classes from checkbox and so many. If we search for app, so this is for app. So this is for app. So from app, one derived class is there called KWVR app, and otherwise app, if you see, it derives from dispatcher, it is also a dispatcher and with object UID. And whereas app contains widget, you can see app contains widget. Like this app contains various others. It contains config parser and then so many. Okay, so this is all about drawing the UML diagram, reverse engineering. So this way you can do reverse engineering for the Python code base, for any kind of packages like we did for Kivy and we have done for Qt and TK Inter also. So for machine learning code base, or for SQL code base, for networking code base, or embedded system code base, or any kind of code base, PyReverse is kind of an ubiquitous tool. It can be used at many places. So for any confusion or doubt, so you can contact us for generating UML diagram while doing the reverse engineering of any Python code base.